Hello, everyone. It's great to be here. My name is Devon Govett. In my day job, I'm the tech lead for React Aria at Adobe, which is our open source, style-free component library focused on accessibility, and React Spectrum, which is our design system. I also created the Parcel bundler, which I'll be talking about today. In Parcel 2.14, released earlier this year, we added support for React server components, which are a new type of component that run only on the server and not in the browser. Aside from letting you do new things with React, like directly access a database, they also help improve code splitting and eliminate network waterfalls, making your app load faster without requiring any changes to the way you structure your components. Parcel is one of the first bundlers that's not tied to a specific framework like Next.js to add first-class support for server components. This makes it much easier for other frameworks to implement RSC support since they don't need to build a whole bundler themselves from scratch. For example, React Router recently introduced experimental RSC support by initially building on top of Parcel. But because the layers are separate, it's also easy to add server components to any app. So here's what it looks like to use directly in code. Since Parcel is not a framework, you're responsible for providing the web server and handling routing and other concerns like that. In this example, I'm using a simple Express server to render a server component to HTML. Separating server components from a specific framework gives you a lot of control over how your app works and enables using server components in new ways. For example, did you know that you can actually integrate server components into any existing client-rendered app without migrating to a new framework by simply fetching them like you would an API? This is actually pretty cool. Fetch RSC in this example is a tiny wrapper around fetch that returns a promise that resolves to a React element. And since React 19 supports rendering promises, you can just return that from a component or even wrap it in another JSX element if you want. And the content that you rendered on the server gets embedded in your client app. There's no SSR to HTML here, just serialized components rendered on the client. Later on, if you want to add, you want to optimize a performance critical page, you can easily add SSR for just that page. I mentioned that server components help improve code splitting, but first let's look at an example in a traditional client-only single-page app or SPA. In this model, there's a single entry JavaScript bundle and routing occurs on the client. Bundlers support this using the dynamic import syntax, which loads a module on demand. A simple client-side router might swap between lazily loaded components based on the URL. But this can introduce a problem. The browser doesn't know which bundles it needs to download until the page loads and the app initializes, which creates a network waterfall. So first the browser downloads the HTML and the entry JavaScript bundle, which checks the URL to see which route needs to be loaded, and then triggers a dynamic import to load additional code for like the dashboard, profile, or settings page, for example. Then the settings page might need to request some data from an API, and maybe it has subpages like account, notification, or appearance settings, which are also code split. So then the browser needs to download more code and make more API requests and so on. You can see where this is going. Every nested route and dynamically loaded component makes the app slower, and the user might see several different loading spinners for each part of the page. We've all used apps like this, and it's not a great user experience. One solution to this is to manually implement preloading code. So the router in the entry bundle looks at the URL ahead of time, realizes that the notification settings page is going to be needed later on, and then starts loading code and data that it needs in advance. But this can be really difficult to implement and maintain in a large code base with many different people and teams contributing, and kind of goes against the whole idea of composition in React. React server components can help eliminate these kind of waterfalls without requiring any changes to the way the components are structured. They do this by merging the server and client into a single module graph, which lets you seamlessly mix server rendering with client interactivity. The use client directive at the top of a file is that one magic line we've all seen that lets the server pass props to the client and enables React and bundlers to preload code and data automatically. But have you ever wondered how this actually works? Well, In Parcel, at least, each module has an associated environment. This describes where the module runs, for example, on a server or in a browser or a web worker, as well as various other properties like the target browser engines to compile for. Environments are actually not a new feature for Parcel, but the use client directive is. Use client does two things. The first is changing the environment to React client. This moves the module into the client bundle that gets loaded in the browser. Second, when a module in the server environment imports a module from the client environment, the bundler creates a proxy module where each export is replaced with a React client reference. This uses an API provided by the React server DOM Parcel package, which is part of the React repo and contains bundler-specific implementation details. A Parcel client reference includes three parts: the Parcel-generated ID of the button module in the client bundle, the name of the export within that module, in this case button, and a list of bundle URLs that must be loaded before the button module can be executed in the browser. So create client reference returns a special object that React knows how to render containing this metadata, and this is what gets imported by page.js on the server. So when the page component renders, the JSX includes this client reference as the button element's type instead of the original button function. Next, React serializes this into an RSC payload, which is a streaming JSON format that gets sent to the browser and deserialized. This includes the button import, which immediately begins preloading, and the serialized JSX tree containing the button client reference and the span that was rendered on the server as its children, along with any other props. And then in the browser, React deserializes the RSC payload back to a JSX tree, and that's what gets used to render or hydrate the page. The client reference becomes a React lazy component, which uses bundler-specific APIs to load the necessary JavaScript files, require the module ID, and get the correct export. This resolves the client reference back to the original button function, which can be rendered just like a regular React component in the browser. This pseudocode is a little bit simplified. The real implementation is a little bit more complicated. You don't really need to know how all this works in order to just use server components, but it's interesting to see how the bundler and runtime work together, right? Parcel also supports CSS in server components. This works a bit differently from client components because CSS is often not included in the JSX tree at all. Here, button.css is imported as a side effect. In client-only apps, the bundler would inject a link element into the DOM when the JavaScript runs, but that won't work on the server because there is no DOM available there. So to support this, Parcel automatically injects link tags into the JSX tree at code splitting boundaries. For example, at the root of each page and in dynamically loaded components. The CSS for all the components that are used on the page gets bundled together, including both server and client components. This relies on a few features in React 19. When a link element is rendered with the precedence prop, React automatically hoists style sheets into the document head and deduplicates them based on the URL. In addition, React suspends until the CSS finishes loading before revealing any components that depend on it, which avoids a flash of unstyled content. This works both during SSR and client rendering and enables CSS imports to work as you'd expect, completely automatically the same way they do in client-only apps. This is another case where the bundler and React runtime work together. So how do RSCs help improve code splitting and solve network waterfalls? Well, I mentioned that each module has an associated environment, and unlike most other bundlers, Parcel has a single unified module graph spanning across environments, rather than splitting each environment into a separate build. This enables code splitting to span environments too. Here's an example where each module is annotated with its environment. The dashboard profile and settings page each have the server environment, and in this case, chart is also a server component, and button and checkbox are both client components. Parcel bundles common dependencies that have the same environment together. Here, dashboard and chart are both server components, so they're bundled together. Button and React are common client dependencies shared between pages, and checkbox is a client component only used by settings. One other interesting thing you might notice is that useClient is actually not an explicit code splitting point like dynamic import. If you import more than one client component, they'll be grouped together into a single bundle instead of split into separate bundles. This is because a page may render many client components, and the goal of bundling is to reduce the number of HTTP requests needed to load the page. If each new client component you rendered resulted in a new HTTP request, that could quickly get out of hand. This kind of optimization is only possible in bundlers that have a unified module graph spanning across environments, because determining which client components to group together into bundles depends on the structure of the server code. If you've wondered why it's taken a bit longer to get RSC support across bundlers, this is a big reason why. Now, returning to the router example I showed earlier, where components are conditionally rendered based on the URL. In the client-only version, this caused lots of network waterfalls as each part of the page loaded and rendered. But with server components, this exact same code doesn't cause any waterfalls, and no manual preloading code is needed either. On the server, dynamic import has effectively zero latency, since it's just loading from disk instead of over the network. And data loaded by server components is usually much faster as well, because the network is faster and much closer to the database or API, which are often in the same data center. Not to mention that it starts loading earlier without waiting for a separate API request from the client after the page loads. When generating HTML, React automatically inserts preload tags for all of the client components that were rendered as part of the response. This works with any level of nesting and in both server and client components. If settings has its own dynamically loaded components, such as notification settings, for example, these will also be preloaded. React also embeds all of the data that the client components will need into the HTML, including data from the databases and APIs that the server components loaded. This effectively flattens the network waterfall, so everything starts loading immediately and in parallel without waiting for each part of the page to render. What's super cool about this is that the underlying component structure in the source code didn't change from the SPA version at all. We still have separate components for each part of the page and separate APIs for each part of the data. These can be maintained by different teams or even live in different repos. But now, rather than slowing down the page by loading in series and adding lots of spinners to the UI, the loading is automatically parallelized. This was a really quick overview of how server components integrate with the bundler. They can help you optimize the loading sequence of your application by automatically parallelizing code and data loading to eliminate network waterfalls. This requires the bundler and React runtime to work hand in hand, and is supported by new bundler features that enable code splitting across environments. React and bundlers like Parcel provide low-level APIs that can be built upon directly by you, or used by frameworks like React Router to simplify the developer experience and add additional features. I didn't have time today to talk about server functions, which also work together with a bundler, but hopefully this talk helped you see how the pieces fit together a bit better. I also wrote a blog post that goes into even more detail if you're curious. Thank you.
Woo. Let's go. Nice.